All right, this lesson is on solving addition equations. It's going to be our first lesson on how to actually work through and solve an equation where we're trying to figure out what could I put in place of the variable to make a true statement. So go ahead and get your notes page set up. We've got our title up here, our learning target in the middle, and then our I can statement down at the bottom. Go ahead and get that filled in, and then we'll be ready to go. So today we're going to solve equations that look something like this. X plus 1 is equal to 8. So one way to think about it is some number, we don't know what it is, so we call it x, plus 1 is equal to 8. Our goal is to try to figure out what that is. Now I know a lot of you are thinking, oh, I already know what the answer is, and that's good. But today's lesson and the next couple lessons are going to be all about how to show what that answer is, not just using mental math. So mental math is not going to be an option in these problems. You're going to actually have to show me, writing it out, how you would solve this equation and how you would prove what the answer is. So here's kind of a model. You don't have to jot this one down. You don't have to draw out this model for this one. Just kind of follow along. If you see in the middle here, I've kind of modeled the equation. On the left side, I have my x. I don't know what it is yet. Plus one little orange or purple circle here. It's equal to 8 of these circles over here. So our goal is to try to figure out what x is. Well, I know what x plus 1 is. I want to know what x is. So what I need to do is I need to get rid of that 1. Here's the rule for today. On both sides of that equal sign, see our line down the middle, you have to treat it equally. In order for your equation to stay balanced, to stay equal, whatever you do to one side, you have to do to the other. So I subtracted 1 away from one side, I have to do the same thing to the other. Now I'm left with just my x, and on the other side I'm left with 7. That's my solution. Our answer is x is equal to 7, because 7 plus 1 gives me 8. And then our last step is always going to be to check our solution, which means take our answer, put it into the equation in place of x, and see if it makes a true statement. 7 plus 1, is that equal to 8? Yep. So we've checked our answer. We know we've done it correct. So let's try a couple of these on our own, or together. So we will have x plus 2 is equal to 7. Go ahead and get this one in your notes. Here's the first thing you're going to do every time you solve an equation. And no, you can't just write down 5. You have to show how do you prove what your answer is. So wherever you see your equal sign, draw a straight line down. Remember from class we talked about an equal sign basically saying each side of that problem has to be equal to each other. So x plus 2 has to be equal to 7. We want to figure out what do I put in place of x to make that true. So here's the rule. Right now we have x, but they added 2 to it. It's kind of like you had some money in your pocket, somebody gave you $2 extra, and now you have $7. But we want to know, what did you start out with? So they gave you $2, so we're going to do the opposite. We're going to get rid of those $2. We're going to kind of remove those 2. But we also have to remove 2 from the other side. Remember, whatever you do to one side, you always have to do to the other side. So you had an extra 2, but I took it away. So I've made that 2 disappear. All I'm left with is my x, whatever I started with. Over here, 7 minus 2 is 5. So I've now used my equation to prove that that missing number x is equal to 5. So we can check our answer, put in 5 for x. 5 plus 2, is that really equal to 7? Yep, 5 plus 2 is 7, so we've checked our answer. Now, it's not a lot of work, but that's the work we need to show on every single one of the problems that we do. Okay? Now, we can also use a bar diagram to model it. So go ahead and jot this down in your notes. Remember from our last unit, if we want to show x plus 2, we would show some amount x, and then we show how we added 2 on to our answer. That's how we would show the expression x plus 2. We're going to use that same idea, but now we're going to add one extra piece. We know that x plus 2, this whole thing, is equal to 7. So now we're going to have 2 parts to our bar diagram. Our x plus 2, and then what it's equal to, which is our 7. Notice how both bars are the same length, which means they're equal to each other. So we can use it to kind of model what's going to happen. We want some number x that when I add 2 extra pieces to it, I get 7 as a total. And we show that that missing number is 5. So let's try another one. Y plus 8 is equal to 15. So again, our first step is always draw that line down to your equal sign. Okay? It's a good reminder that says whatever you do to one side of that equal sign, you have to do the same thing to the other side. So on our left side, we have our variable y plus 8. So we had some amount and somebody added an extra 8 to it. Well, I just want to know what I start with. I don't want to know what I have now when I added something extra to it. So I kind of need to get rid of that 8 that they gave me. So they added 8, so I do the opposite. I subtract 8. But I have to do the same thing to both sides. In order for it to stay equal, I have to treat it the same. So I had some amount y and added 8 to it. But then I took that same 8 away. It's kind of like it was never there before. Now I'm just left with my y. So the whole goal is to try to get y all by itself. I don't want to know what y plus 8 is. I just want to know what y is. On the right-hand side, 15 minus 8 is 7. So if I've done this correctly, my missing number is 7. So let's check our answer. 7 plus 8. I just put in 7 in place of my y. Is that equal to 15? Hopefully you said yes. That's our answer. 7 plus 8 is equal to 15. Okay? Now, you may have already known that the answer was 7, but the rule is you have to be able to prove it. So all of this work that we've shown up here, drawing the line down the middle, showing that we're subtracting 8 from both sides and what we get for answer, along with checking our answer, are all going to be required when you solve these problems. It's not optional for us. Okay? Let's also do a bar diagram for it. We need some practice with it. So we want to show y, so some amount y, plus 8. So that's our left-hand side of the equation. So we start with that one. We know that whole amount is going to be equal to 15. So what we're really thinking is some amount y plus 8 is equal to this total of 15. So we know it's going to be something a little bit smaller than 15, and we can use our equation over here to help us figure out what that's going to be. Okay? So let's do another one. 3 plus w is equal to 24. If you think you've got the right idea on how to solve the equation, how to show your work, how to draw the bar diagram, feel free to pause and try it on your own, then hit play and see if you did it right. If not, if you're still a little iffy, go ahead and follow along with me as we do one more. So first step is always draw that line down through your equal sign. Split the problem into 2 halves. Remember, whatever you did to one side, you have to do to the other side. Focus on the side with your variable, 3 plus w. So some amount w, and they added 3 to it. To solve an equation, you always want to do the opposite. They added 3, so I want to subtract 3 to make it go away. I want to get rid of that 3, so all I'm left with is my w. But the rule is, whatever you do to one side, you have to do to the other side. You have to keep it equal. Okay? There was 3, but I took it away. 3 minus 3 is 0, so that piece disappeared, and all I'm left with is my w. That's our goal. We want to get that variable all by itself each time. 24 minus 3 is 21. So if we've done the problem correctly, we should be able to plug a 21 in for our variable and make it a true statement. So down here we try it. 3 plus 21 in place of our w. Is that equal to 24? Yep, we did it correctly. If you ever check your answer and it doesn't quite work out right, that's a good indication that somewhere up in your equation we made a mistake. We need to go back and give it another try. So let's do our bar diagram. We're practicing both the equation solving and the bar diagram. So here we want to show 3 plus w. That's what our left side of the equation says. And we know it's going to be equal to, so the same size as 24. So this part up here is one side of the equation. This part down here is the other side, but notice how they're both the same length overall, which shows us that they're going to be equal to each other. So that's how we solve our addition equations and how we show our work. Again, it's something you have to show those steps. No cutting corners, no skipping over things. You have to show that work on both sides of the equation all the way through. All right, last couple. For these, we're just going to use the number form. We're not going to draw our bar diagram for it. But we can do the exact same thing that we have been with whole numbers. We can do the same thing with our decimals. So jot the equation down and then draw our line down through the middle. We want to solve x plus 2.8. So some number plus 2.8 is equal to 7.3. Well, again, our goal is to get x by itself. We just want to know x is equal to blank. So we need to get rid of this 2.8. Well, they added it on, so we do the opposite. We subtract it away. But we have to do the same thing to the other side. And we're always trying to keep it balanced, keep it equal. They had 2.8. We subtracted it away. So we're just left with x. That's our goal. 7.3 minus 2.8. Going to have to do a little subtraction here. Remember to line up your decimal point and it just drops straight down. And we get an answer of x is equal to 4.5. So always check your solution. And yes, you do have to check your solution each time. Put in 4.5 for x plus 2.8. We want to know, is that really equal to 7.3? If you're not sure, do some quick math off to the side. 5 and 8 is 13. 1 plus 4 is 5, plus 2 is 7. Drop down a decimal point. So we've checked our answer, we're good. Last one. Same rules apply, even though there's fractions. Doesn't matter, we're just solving our equation. So we draw our line down through the middle. We want to know what x is. We want to know that missing number. And we know that if I were to add 4 11s to it, I would get 9 11s. So I need to work backwards. I just want to know what that x is. So they added 4 11s. I want to make it go away. So I do the opposite. I subtract 4 11s. But I have to treat both sides equally. So I do the same thing on the left-hand side. They gave me 4 11s. I got rid of it. So they cancel each other out and disappear. And we're just left with x. 9 11s minus 4 11s is 5 11s. Probably what you thought the answer was going to be, but now we actually proved it. We know for certain that's our answer. Now let's check the solution. Plug in 5 11s for x plus 4 11s gives me 9 11s. That's what I wanted. So my answer is correct. And that's how we use equations that's how we can solve an equation by showing our work and checking our solution.